You're listening to the N2K Space Network.
Hey everybody, Dave here. I've talked about Delete Me before, and I'm still using it because it still works. It's been a few months now, and I'm just as impressed today as I was when I signed up. Delete Me keeps finding and removing my personal information from data broker sites, and they keep me updated with detailed reports, so I know exactly what's been taken down. I'm genuinely relieved knowing my privacy isn't something I have to worry about every day. The Delete Me team handles everything. It's the set it and forget it peace of mind. And it's not just for individuals. Delete Me also offers solutions for businesses, helping companies protect their employees' personal information and reduce exposure to social engineering and phishing threats. And right now, our listeners get a special deal, 20% off your Delete Me plan. Just go to joindeleteme.com/N2K and use promo code N2K at checkout. That's joindeleteme.com/N2K, code N2K.
When we think of the future capabilities of the space industry, in-space servicing, assembly, and manufacturing, otherwise known as ISAM, is poised to make what was once thought to be impossible in space a reality. So how is the United States preparing the future workforce for what's coming? Well, Cosmic is leading the way. Welcome to T-Minus Deep Space from N2K Networks. I'm Maria Varmazes. The Consortium for Space Mobility and ISAM Capabilities, otherwise known as Cosmic, is a nationwide coalition working to invigorate a domestic ISAM capability. Cosmic has just wrapped up the first Cosmic Capstone Challenge, otherwise known as the C3. And I spoke to Sita Raghavan and Joy Haing, who walked me through the C3 and the plans for its development.
Hello, everyone. I'm Sita Raghavan. So I'm actually a professor of aerospace engineering from Embry-Riddle Aeronautical University. And my areas of research are in materials in extreme environments, mechanics and materials in extreme environments, looking at space, hypersonics, and engines, and everything that's really tough on material. And so I do research, and I also take care of a group of students, run a lab, come up with great ideas. And I'm serving as the academic caucus chair of Cosmic. So that's a part of the service I do to engage with the community in areas that are up and coming, in areas of research that I'm interested in.
Awesome. And I can't wait to hear more about all of that after Joey does his intro. So Joey, without further ado, please tell me about yourself.
Hi, my name is Joey Haing. I got a bachelor's degree in aeronautical and astronautical engineering from Purdue University, and I got a master's in space systems engineering from Johns Hopkins. Day to day, I do a lot of conceptual design, kind of early mission formulation work at the Aerospace Corporation, working as a space systems architecture engineer, supporting our concurrent design center. And got tied in with ISAM, so that's in-space servicing, assembly, and manufacturing, a few years ago, and got looped into Cosmic, which is the consortium for space mobility and ISAM capabilities, nested acronyms there, and specifically help
well done.
The workforce development focus area and the academia caucus with Sita, engaging with students, trying to figure out how to, kind of reshape how students think about space missions in general, but really how to figure out, how to engage ISAM and get ISAM into different programs. So specifically working this year with the Cosmic Capstone Challenge, C3, we call it, where we've been working with numerous universities and a few high schools to provide a prompt for a conceptual design for the space mission.
Awesome. Well, thank you both so much for joining me today. And as our audience can probably surmise, we're going to be talking about Cosmic and also C3 and just how things have been going. Because it's a really, really cool program. And it's very exciting to see the progress there. So, Sita, I'm going to go back to you. If you can sort of From your viewpoint, from where you stand, how is Cosmic going? I mean, what has been the progress in the last year? Like, what have you been seeing?
Well, I'm really excited about Cosmic because first of all, it addresses something and a really growing area, industry focus. I mean, it is something that's up and coming, and in a short time of 1.5 years or so, we've got together a group of people who have been working for many years on topics that are all relevant to ISAM. Um, and that's in space servicing, assembly, and manufacturing, right? And these people have been working individually on various areas. And because ISAM is so multidisciplinary, imagine, having this disparate group of people working in areas. Cosmic is really what glues us together. And in this short time of 1.5 years, we've managed to get a whole bunch of people coming together, working on areas of research, product development, workforce development, you name it. And we've started thinking about all of that. And that's really important right now because we are in the stage of building up this whole concept of ISAM and all that's needed for it, standardization, what's needed for students to learn to be able to contribute to ISAM. So these are things that we need to start building from scratch, and bringing the right people together is what Cosmic has done. So I'm pretty excited that we've managed to accomplish that in such a short time to get everybody together. But we've got a long way to go in terms of the amount of what's needed right now to get ISAM off the ground. And I think we've got the energy and excitement to do it.
That is a very exciting development. And also, I mean, honestly, ISAM itself is such a fascinating field. And being in academia at this time where, as you said, we're trying to figure out what kinds of programs are needed to support this fast-growing new frontier. Are we at the point where we have even the beginnings of frameworks? Like, where are the conversations in academia right now? Can you give me sort of, if I was a fly on the wall, what would be happening?
Well, I could add to that. I think in academia right now, definitely there's an existing history of a lot of background and courses that have been supporting what needs to go into ISAM. But we need more targeted topics and focused areas that just address the ISAM needs, and sort of bringing that together so that it's going to be able to train a student who's able to contribute to all aspects of ISAM. And when I said multidisciplinary, I'm talking automation, robotics, materials, manufacturing, you name it. It's physics, it's science, it's engineering. All of it comes together. So all of these are pieces all over the place, and getting course content and getting the people in the room who know what the course content is, that would help this focus area grow. That's, I think, a big deal. And that's what academia is trying to address right now. And the way we're doing it, of course, individual institutions are starting to see, well, here's how we can contribute. We've got these expertise, and here's what we can do in terms of course content. But really, we need an overall strategy for the nation so that we are really addressing all aspects of ISAM, and that we are not missing some focus area, some workforce area that falls behind, because without each one of that piece, every piece is important to get that successful mission for ISAM going, right?
I think the Cosmic Capstone Challenge was really designed. My co-lead with workforce development, Jacob Rome, the past 2 years have been leading this concept called the Orbital Manufacturing Initiative. And so we had been more ad hoc, but really trying to engage students on, sort of this, high level payload concept design to figure out, hey, you're a student, you haven't been in industry for 10, 15 years. What are ideas you have without you don't have the concept of limitations right now, right? So what, from a pure function and utility standpoint, what can you think of, right? And so, specifically with C3 this year, kind of taking Jacob's program and then putting it under the Cosmic banner, we really gave students an open-ended prompt, just design some sort of payload to be hosted about a small satellite bus, try to do 3 or more operations autonomously. But besides that, we can say, try to support, ISAM. It doesn't have to be just servicing or just assembly or just manufacturing. It can be whatever you want to do, right? And so, like Sita's saying, it's not just targeted for aeronautical or astronautical students, but it's also targeted at mechanical engineers or electrical engineers or computer engineers that are working on vision systems, things like that, right? So, just to add on what Sita's saying, it's a multidisciplinary problem, and we're trying to target it from those different angles, right? And doing that by giving an open prompt this year, and then next year dividing the C3 challenge into 4 unique prompts focused on orbital manufacturing, assembly, lunar operations, orbital servicing, as well as another kind of more in like on-surface assembly system, robotic assembly. And so, by doing that, we're directly engaging with, what Sita's saying as well, engaging with industry and academia, specifically, rather than just hosting it on an example payload bus, we're actually working with David Barnhart of USC, University of Southern California, who also runs a company called Arcasys. And so we're actually working with them to get, interface control documents so that we can send, actual technical specifications to the students, give them CAD renderings so they can actually see, hey, here's directly what you're mounting onto, how can you fit within this volume, how can you meet the power requirements here, but still giving them the flexibility to design from there, right? But just saying like, hey, here's your baseline, go off, have some crazy fun ideas, things like that.
I was just going to say the multidisciplinary angle that you both have mentioned, it also really aligns well with what we're hearing from the industry about how much we need these different approaches, and we need to be thinking about application outside of sort of the standard silos and breaking out of those silos entirely. So go ahead, Sita. Yeah, go ahead.
Oh, yeah. I wanted to say Joey's and Joey and Jacob have done this immense effort. And I think one thing that's like, we got to realize is that students out there, they don't even know what ISAM is. And all of us professors are going to talk about, these multidisciplinary areas, and it kind of goes over the top of everyone's head. But, that challenge, it does it. You can take anyone from high school and they now know exactly what ISAM is. And you can't get people interested in doing the courses for it or thinking of a career in it if they don't know what it is that they're going to get into. So I think just the knowledge of what ISAM is and getting that across in simple ways just through this project and this hands-on effort just gave everyone involved an idea of this could be something I want to be part of as part of my career.
Yeah, and to add on to that, I mean, some of the ideas we're seeing here are, they're beautiful in their simplicity, right? Like you obviously have crazy, wild, out there ideas that may take many years to develop, but you also have.
I would hope so.
Yeah, right. But you also have these more near-term ideas where it's like, oh, I didn't think of that, right? Like the winning team from Cal State LA, Space Bender, it was literally just bending wire in space. It was very simple. You don't have to focus on any complex welding or how do you deal with metallic powders in space or anything. It's literally, hey, if we can get this filament up there, how can we just bend a structure into space? You don't have to worry about the launch environment. You don't have to worry about launch loads. And so, those sorts of ideas where, students come in with no background, on how a notional space mission works. And they say, oh, this could work. It's pretty simple. It's a small payload, whatever. And then looking at those ideas and figuring out, hey, how can we take this concept and connect you with, people connect, the big thing about the program is we connect each student team with a mentor from industry, from or government or academia. That is directly part of Cosmic. So, they're meeting with these mentors every week or two. And so you get these ideas where, depending on a mentor's, expertise, they kind of, can push or guide the students different ways. But you get, a lot of really creative ideas, really, really fun, exciting ideas. And then you get ideas that, are just almost ingenious in their simplicity and more from an application standpoint are really great.
We will be right back.
Worried about cyber attacks? CyberCare from Storm Guidance is a comprehensive cyber incident response and resilience service that helps you stay prepared and protected. A unique onboarding process integrates your team with industry-leading experts. So if an incident occurs, your response is optimal. Get priority access to deeply experienced responders, digital investigators, legal and crisis PR experts, ransom negotiators, trauma counselors, and much more. The best part? 100% of unused response time can be repurposed for a range of proactive resilience activities. Find out more at cyber.care/cyberwire.
What does every USAA member have in common? Family. We're one big family who supports the military community and their eligible families. And if you, your parent, or spouse served, you could join our family and save big on auto insurance. Visit USAA.com/join today to check your eligibility. Membership eligibility and product restrictions apply and are subject to change. USAA means United Services Automobile Association and its affiliates, San Antonio, Texas.
Yeah, I was going to ask if y'all had any favorites from what you saw, because the C3 just happened, didn't it?
Mm-hmm.
So this is fresh in both of your minds. I would love to hear about, because you just mentioned the Bender one just made me think of Futurama. So that's where my head's at right now. But that's really cool. I love that idea. And I know there were a lot of really fascinating ideas, and I'd love if there are any other favorites that you have. If you want to walk me through any of those, that'd be great.
Yeah, I mean, a lot of different unique ideas, obviously. A lot of like orbital debris missions as you see typically. But I think, Sita, if you want to talk about some of like the high school teams that you were supporting, I think that was another spot where you're seeing, maybe not as much analysis behind it, but you're seeing these really creative like rover concepts and things like that. So if you want to speak to what Shasta was up to.
Yeah, I think for me it was like just I managed to sit in on Shasta's presentations for the ISAM projects, and I think the biggest thing for me is I loved all the ideas, but what I really enjoyed was just seeing how they are all energized by these ideas, right? And then they start troubleshooting and they think about all that could go wrong, and so I think that whole process of thinking through, and every team had that. So I'm just excited about all of their projects. And it's like Joey said as well, the ideas are sometimes so simple, and, it tends to be that because we know what the problems are or what the environment can create, we tend to limit ourselves sometimes. And just being open, like those students, they're not like, concerned about some of these things, and it's necessary to think out of the box like that and help us as well. So I really enjoyed all of their topics.
So you worked with Shasta High School. Was that in California? Is that one of the high schools you worked with?
Oh, well, I managed to listen to some of their projects. So,
okay.
Yeah. And, we have in the academic caucus, the academia caucus, we have representatives from different universities, colleges, and high schools, and Shasta is one of them. And Brian, who's the teacher of and in charge of the high school students over there, has been really a great mentor to his students. And you can see that they all kind of start to realize whatever they're doing is really important. People want the answers, So
yes. Yep.
Yeah, so we get to be part of that. He helps set things up so that we can listen to the students, and they get to, get in touch with industry and as well as people like me in academia, and just seeing external people look at their ideas and give them feedback and are excited about that. That really brings up their excitement levels too.
Yeah, Brett Barnes and Brian Grigsby from Shasta High School have done just a phenomenal job. It's not just concept development. We gave the option for teams depending on, to be flexible with program requirements. We said, hey, if you want to build a prototype, go for it. And it was actually, these students are like welding in high school. They're actually like building like metal prototypes that you're seeing. So that was really exciting.
Wow.
And I mean, cool. Just some of the engagement we saw even in just this first year was fantastic. Professor Sarah Lego from Penn State. We'd spoken with her last spring and said, hey, we're thinking about doing this. We gave her our draft material. She was like, hey, I have this, quick turn summer program. We'll see if the students like it. We'll kind of test it out here. And then she ended up signing up 10 teams. It was like 66 students, I think, all from Penn State. So, when we had this final showcase last month, we gave 2 in-person location options. So if you're kind of more in the Western U.S., you could come down to LA to the Aerospace Corporation, present in person, but then also get lab tours and see what we're up to. And then for the students, like the Penn State teams, for example, they drove out to NASA Goddard in Maryland. And
Not bad.
got to present there, but they also got to tour the facilities and see real hardware in real space labs. So it was really exciting.
That is so cool. My mind's just a little blown thinking that we have high school students working on ISAM projects. That is genuinely just really impressive and speaks so well to how much academia, the industry, the space community knows that this is really where we need to be building workforce expertise and certainly letting younger people understand like this is a really important area where they can really move the needle very quickly is fascinating. Joy, you mentioned that there's already planning for next year and some changes afoot, some really exciting developments. I think you mentioned a few of them, but can you just maybe go over them for me just so I can understand what we're looking forward for next year?
Yeah, so next year we're trying to really expand in terms of numbers, obviously. We had over 200 students. We had between like 230, 240 total students. And we're really planning on growing. We're talking to a lot of universities right now, getting feedback from the mentors, getting feedback from the judges that served in our competition, as well as some of the advisors, figuring out what worked well and what didn't. And so part of that is we're really looking at adopting more of a almost like champion type system where we have 4 tracks. So you have orbital manufacturing and assembly. You have kind of a lunar oriented surface operations. You have orbital servicing, so kind of like a refueling type mission. And then you have an actual like in space, robotic assembly. And so for each of these, we're working with industry and government partners to get sort of a main point person to run each one of these. So at our convergence event next month in Los Angeles, we're having each of these champions kind of go up and speak about the importance of each of these topics, why we're dividing up into 4 tracks, and then if you're a student. Next year, you can look and say, oh, which one of these 4 looks most interesting to me? Which one's most applicable to the program I'm in? Maybe they're choosing that. Maybe the professor's choosing that. We're willing to kind of let them sort it out too. We want to just maintain that flexibility, and then planning on giving more guidance into, hey, if you have a bigger team, maybe this challenge is a little harder, right? Like maybe doing full scale lunar operations, designing a rover, designing sort of a ConOps of what you're trying to accomplish. Maybe that's a bit larger scale. And maybe, doing more of just like a simple payload design that may be a little smaller scale, right? So we want to be flexible in terms of, maybe a larger university, maybe they have funding to build a prototype, maybe smaller universities, they don't, right? So we're not trying to lock any students into any one path, but giving them the option to say, hey, if your expertise is, in envision systems or your expertise is in propulsion, there's different areas you can go into that make sense. And again, giving the advisors, giving the professors, some flexibility so that they can, meet with their department and say, hey, here's where we want to go, and not lock them into, one path, but give them those options.
Sita and Joey, I just want to make sure I give you both an opportunity to share any last thoughts with the audience before we close out today. Why don't we go Sita and Joey in that order? If there are any thoughts you want to share before we head out.
Yeah, I do want to say that, Cosmic is still growing, and we do need more academic, participants. So we want to kind of make sure that everyone out there knows that this is a place where you can really contribute, and there are so many. This is a field that is growing so rapidly. It really is a community of people coming together that. It's so many different ideas with so many different ideas, and we are all open to these ideas. So there isn't one area. Again, it's multidisciplinary. We're talking about damage, radiation damage, materials, automation, robotics, whatever your interest is. You're going to be able to find something that you know about that's going to be relevant to ISAM. So consider thinking about putting your group together and looking at the challenges, or if you're a student, get your faculty involved, and if your faculty gets your students involved, and be part of this exciting group.
And then, for me, I think, just like Sita was saying, it's only the first year we've been doing this. We've seen a lot of growth, but this is by no means a finished product. So looking for feedback on C3, looking for more teams if you're part of a student club or part of a university or have colleagues that work at a university. You can go to cosmicspace.org/C3. You can find all of our information there. Provide feedback. You can find emails, reach out to myself or Jacob Rome, the workforce development co-lead. I think the future is bright. The first year was very successful, but definitely still learning and growing. So thank you.
That's so great. Joey and Sita, thank you so much for joining me today. I really appreciate it.
Yeah,
Thank you.
That's it for T-Minus Deep Space, brought to you by N2K Cyberwire. We would love to know what you think of this podcast. You can email us at space@n2k.com or submit the survey in the show notes. Your feedback ensures we deliver the information that keeps you a step ahead in the rapidly changing space industry. N2K senior producer is Alice Caruth. Our producer is Liz Stokes. We're mixed by Elliot Peltzman and Trey Hester, with original music by Elliot Peltzman. Our executive producer is Jennifer Iben. Peter Kilby is our publisher, and I'm your host, Maria Varmazis. Thanks for listening. We'll see you next time.
And now a word from our sponsor, SpyCloud. Identity is the new battleground, and attackers are exploiting stolen identities to infiltrate your organization. Traditional defenses can't keep up. SpyCloud's holistic identity threat protection helps security teams uncover and automatically remediate hidden exposures across your users, from breaches, malware, and phishing to neutralize identity-based threats like account takeover, fraud, and ransomware. Don't let invisible threats compromise your business. Get your free corporate darknet exposure report at spycloud.com/cyberwire and see what attackers already know. That's spycloud.com/cyberwire.